What's going on, everybody? Today, we are going to be discussing the merge. The merge is the merge between the beacon chain and Ethereum's mainnet, and it's coming sometime mid-September. If this is something that you're wondering about, we're going to discuss in detail what the merge is, what it means to go from a proof of work to a proof of stake system, which if you haven't already, check out my previous video on proof of work versus proof of stake. We're going to discuss the algorithms behind the proof of stake that Vitalik Buterin wrote a white paper on. We're going to talk a little bit about layer 2 solutions and how they're addressing the scalability issue of Ethereum. And then we're going to finish with the next milestone on the Ethereum roadmap, which is sharding. So if this sounds like something you're interested in, join me as we discuss the details and the articles published on the merge. So the first article we're going to be discussing today is on the Ethereum.org website detailing what exactly the merge is. Soon, the current Ethereum mainnet will merge into the beacon chain, which is the proof of stake system, all proof of stake being a consensus mechanism. This will mark the end of proof of work for Ethereum and unfortunately for all the miners that are part of the network, and the full transition to a proof of stake mechanism. This sets the stage for future scaling upgrades to include sharding, which we're going to discuss at the end of this video. And the big ticket item here is that the merge will reduce Ethereum's energy consumption by 99.95% by eliminating proof of work and all the miners that are expending energy in order to maintain the integrity of the network. When is this expected? Well, current estimates are anywhere between September 15th and September 19th. The merge is the most significant upgrade in the history of Ethereum, which is why it's been tested for so long. And unfortunately, we've experienced so many different delays because this is radically changing the way that we use consensus mechanisms on the Ethereum protocol. So really, what is the merge itself? Well, the merge represents the joining of the existing execution layer, which is currently what's considered mainnet on Ethereum, with its new proof of stake consensus layer called the beacon chain. Now, the beacon chain launched independently of the Ethereum mainnet, which is currently what we're using today, back in December of 2020. When that launched, people were offered the option to become a validator on the network, and they could stake their Ethereum and earn the rewards. So if you were a participant in the system, you would have already staked your Ethereum in the form of a smart contract, and you would have been earning ETH 2.0 rewards up until the actual merge itself. Now, what they're planning to do at the actual merge date is to literally merge the execution layer, which is the Ethereum mainnet, with the consensus layer, which is the beacon chain. The analogy that they use is they're swapping planes mid-flight. So imagine Ethereum mainnet with a bunch of passengers on board mid-flight. It's going to swap with the beacon chain and it's going to merge into one. So you will have the execution layer and the consensus layer on top of it. So it's important to remember that initially the beacon chain shipped separately from the mainnet. So when people were saying that they were testing either different test nets, what they were doing is they were taking the beacon chain, merging it with those test nets to work out all the kinks and bugs and identify any of the issues with the code itself. So with all of its account balances, smart contracts, and blockchain state, it continues to be secured by a proof of work, which is currently what we have today. Throughout Ethereum's history, developers have been working hard to prepare for an eventual transition to from proof of work to proof of stake. Vitalik Buterin, as long as he's been around the space and as long as I've been following him, has always talked about adopting the proof of stake model. So you may be wondering what proof of stake is. And if you are, check out my previous video on proof of work versus proof of stake. Well, what proof of stake is a cryptocurrency consensus mechanism, so a means to agree with invalidators for processing transactions and creating new blocks on the blockchain. So what's a consensus mechanism? Well, a consensus mechanism is a method for validating entries into a distributed database and keeping the database secure. Okay, so that consensus mechanism, either proof of work or proof of stake, is just a method for validating all the entries that are getting added into the blocks, which is the distributed database being the blockchain protocol, and keeping that database secure. In the case of cryptocurrency, it's called the blockchain. So the consensus mechanism, in essence, secures the blockchain. For proof of work, that's currently what's used not only to incentivize miners, but also to secure the blockchain protocol. And for proof of stake, it's doing the same thing. It's just incentivizing the participants of that system in a very different way, which we'll discuss here shortly. So with proof of stake, cryptocurrency owners validate block transactions based on the number of coins a validator stakes. So in the case of proof of work, you expend capital in the form of energy, with one vote being one hash, the more hashes you have, the more votes you have in that consensus mechanism. For proof of stake, rather than expending energy to the form of the rigs and the miners, you're actually physically staking those tokens, and each one of those tokens is worth a certain amount of votes as a consensus mechanism. Proof of stake was created as an alternative to proof of work, which proof of work being the original consensus mechanism used to validate a blockchain and add new blocks. Famously, in Satoshi's white paper, when he created Bitcoin, where he, she, they, whoever it is, proof of work was the core of the consensus mechanism that made that database secure and currently exists to this day. While proof of work mechanics require miners to solve cryptographic puzzles by expending energy to solve that cryptographic hash, proof of stake mechanisms require validators to simply hold and stake the tokens. So instead of expending energy to mine the blocks, for proof of stake, the next validator is selected at random. That random validator then accounts for all the different account balances that are happening within that set period of time and then puts it out on the network. A bunch of different validators vote on whether or not that's a valid transaction. And if you're found to be either dishonest or malicious, like in the case of an attacker, you physically lose that stake. Whereas for proof of work, you take the risk by being a malicious actor by spending all this money on energy and all these hashes only to find out that the network itself of validators doesn't agree with you. So think about it this way. In a proof of work model, you spend energy to be a participant in the system in the hopes of a reward. In the case of Ethereum, you physically stake or you risk the coins and you receive a reward based on the proportion of coins that you actually stake in the system itself. Proof of stake is seen to be as less risky in terms of the potential of an attack because you'd have to buy 51% of all the staked tokens. Currently for Ethereum, that's around $15 billion. Now here's the key factor for a proof of stake consensus mechanism. The next block writer on the blockchain is selected completely at random, with the higher odds being assigned to nodes with larger stake portions. So in the case of Bitcoin, where the next block writer is whoever solves the cryptographic hash and then propagates it to the network, in a proof of stake model, it's completely selected at random, and it's based on proportionally how many coins that you have staked in the actual Ethereum ecosystem. If you want to get a little bit more into exactly what proof of stake is, I'll leave this in the comments below. The big things to compare the two side by side, for proof of stake, block creators are called validators. In the case of proof of work, block creators are called miners. In the event of proof of stake, participants must buy coins or tokens to become a validator, whereas for proof of work, participants must buy equipment and energy to become a miner. Proof of stake is energy efficient, whereas proof of work is not really energy efficient. Proof of stake allows for more scalability, while proof of work does not allow for more scalability. Proof of stake network control can be bought, whereas for proof of work, robust security due to expensive upfront requirement of buying all the equipment. For proof of stake, validators receive transaction fees as rewards, whereas in a proof of work model, miners receive the block rewards. Proof of stake. Well, on the Ethereum.org website, they do a really great job breaking down exactly what proof of stake is and how it applies to the merge. Proof of stake, again, is just a consensus mechanism that Ethereum will use after the merge, which is sometime mid-September. Ethereum is moving off of a proof of work to a proof of stake because it is more secure, less energy intensive, and better for implementing new scaling solutions. So the why behind the entire merge is because it's more secure, it's less energy intensive, and it's better for implementing new scaling solutions, which we'll talk about with layer 2 scaling solutions. Right now, the minimum requirement to be an ETH validator node is 32 Ethereum. And what you do is you deposit that Ethereum to the Ethereum network in the form of a smart contract. This staked Ethereum then acts as collateral that can be destroyed if the validator behaves dishonestly or lazily. So this is how they're maintaining the integrity and security of the network. Because if you stake your Ethereum and you're trying to fraudulently either change different account balances and then other validators call you out for it, or you try to create Ethereum out of thin air, then you lose the entire stake of your Ethereum, which right now 32 ETH runs you about $50,000, so that's a pretty expensive mistake to make. The validator is then responsible for checking that new blocks propagated over the network are valid and occasionally creating and propagating new blocks themselves. Proof of stake comes with a number of improvements to the proof of work model. So there's better energy efficiency. There's lower barrier to entries because all you really need is a Raspberry Pi, a constant internet connection, and 32 ETH, which is quite a bit of money at this point. There's reduced centralization risk, being that in a proof of stake model, all you have to do is buy coins to be a participant in the network. Right now, in most proof of work models, it belongs predominantly to mining pools or big corporations that have thousands and thousands of GPUs and all these different mining rigs with a high hash rate. Because of the low energy requirement, less Ethereum issuance is needed in order to incentivize participation. So this is actually how Ethereum is going from a slightly inflationary model to a deflationary model. Because of EIP 1559, they're actually burning more Ethereum tokens than they're adding by the rewards on the different blocks that are added to the blockchain. Economic penalties for misbehavior make a 51% style attack, which means you take over half of the network or half of all the staked Ethereum on the network, exponentially more costly for the attacker compared to proof of work. The estimate is somewhere in the low billions to launch a 51% attack on the Ethereum network as it exists in proof of work. But for proof of stake, you would have to buy 51% of all the staked Ethereum, which people would start to notice is happening, and it would cost you around 15 billion, so it's even more unlikely. And the community can resort to a social recovery of an honest chain if a 51% attack were launched. So even if someone was successful in obtaining 51% of all the staked Ethereum, then what the honest participants could do is essentially launch a hard fork on the last known honest block and then continue that network. So that'd be a pretty costly $15 billion mistake. TheMerge.com has a lot of awesome information to explain exactly how the merge is going to take place. So as you can see with this visual diagram, the proof of work or Ethereum mainnet system will then come to some position where it's going to merge with the proof of stake, and all of the validation that will happen as a consensus mechanism and all the rewards that are given to the validators will then follow that proof of stake model from the date of the merge and onward. Vitalik Buterin has been talking about the merge and moving to a proof of stake system since the inception of Ethereum. There were a lot of different theories on which algorithm he was used or which proof of stake consensus mechanism. Started with the slasher, then consensus by bet, and they eventually settled on Casper, the friendly finality gadget in 2017. While the beacon chain provides an elegant solution to transitioning the Ethereum consensus algorithm, the Ethereum network will not live in split 2 forever. So really what's happening, and to fully realize the transition to proof of stake, Ethereum's history in the proof of work network, so all of the blocks that have ever existed throughout history since its inception will be preserved as we move to that proof of stake consensus layer. Essentially, the proof of stake consensus mechanism is only replacing how they incentivize the participants of the system that maintains the security, which are going from miners to validators, and the consensus mechanism by which people are assigned to write the next block, which in the case of Ethereum is selected randomly. Now, really to understand what the merge is targeting, you have to understand the scalability trilemma. Vitalik Buterin constantly talks about this issue where you have decentralization, scalability, and security. And those are all 3 different points of the triangle, but unfortunately for most solutions, or what they call simple solutions, you can only address 2 of the 3 of those. Scalability is the chain can process more transactions than a single regular node can verify. For decentralization, the chain can run without any trust dependencies on a small group of large centralized actor. This is typically interpreted to mean that there should not be any trust of a set of nodes that you cannot join without a consumer laptop. And security, the chain can resist a larger percentage of participating nodes trying to attack it. The merge is trying to address decentralization and security by moving to a proof of stake consensus mechanism. For decentralization, moving to a proof of stake system reduces the large buying power that a lot of these mining pools have with all the expensive hardware and these large organizations that own the majority of the hash rate within the ecosystem. And it's moving down to a proof of stake where you can stake a node with simple things like a Raspberry Pi and whatever Ethereum you deposit on a smart contract. For security, it's addressing this issue by making Ethereum harder to hack or harder to launch a 51% attack. For proof of work, you have to own 51% of all the computing power, and it's hard to move away from that once the attacker gains control of the network. Whereas for a proof of stake consensus mechanism, you'd have to purchase 51% of all the Ethereum or whatever cryptocurrency is staked in order to launch the attack. And even if you did that, you could always reverse the attack by going to the last hard fork and forking your own chain. So what are we doing about scalability? Well, The merge itself is not necessarily addressing the scalable issue. It's not going to increase the transactions per second in the network or the throughput of transactions, which is where layer 2 solutions really come into effect here before sharding takes place. And what is layer 2? So layer 1 is the baseline blockchain protocol. For Ethereum and for Bitcoin, it's the actual BTC or ETH tokens. That's essentially the basis of the protocol network. A layer 2 is a collective term to describe a specific set of Ethereum scaling solutions. So layer 2 solutions are their own cryptocurrency, but they're bridged or connect to that underlying layer 1 protocol, in this case being Ethereum. A layer 2 is a separate blockchain that extends Ethereum and inherits the security guarantees of Ethereum. So oftentimes it'll relate back to transactions or even finalize a lot of blocks on the Ethereum blockchain, but it'll handle a lot of those transactions off-chain or whatever layer 2 scaling solution it is to reduce the burden that's on the Ethereum network itself. So what is layer 1? Well, layer 1 is just the base blockchain. So for Bitcoin and Ethereum, it's the BTC or the ETH tokens. They're both layer 1 blockchains because they are the underlying foundation that various layer 2 networks build on top of. So think whatever protocol is the base of it, whatever layer 2 solutions are on top of that, feed into the layer 1 solutions, but they also help address that scalability issue by increasing capacity of the layer 1 network itself. Examples of layer 2 projects include rollups, which we'll discuss here shortly, on Ethereum, and the Lightning Network, which exists on top of Bitcoin right now. So Ethereum as a layer 1 includes a network of node operators, a network of block producers, the blockchain itself and the history of transaction data, and a consensus mechanism for the network, which we're moving from proof of work to a proof of stake. So really, why do we need layer 2? Well, there's 3 desirable properties of a blockchain like we just discussed. There's decentralization, security, and scalability. Ethereum has reached the network's capacity with 1+ million transactions per day and high demand for each of these transactions. The success of Ethereum and the demand to use it has caused gas prices to skyrocket. So back when the NFT craze was really hitting hard in 2021, you saw gas fees go through the roof because the capacity of the network could not handle all the transactions that were happening on the layer 1 blockchain. This is why it's so important for a lot of layer 2 scaling solutions to take a lot of those transactions off chain, but then handle the finality of those transactions on the layer 1 blockchain. The main goal of scalability is to increase the transaction speed, so faster finality, and transaction throughput, which is transactions per second, without sacrificing decentralization or security. So with the merge addressing decentralization and security, the layer 2 solutions can address the scalability issue to increase capacity of the network. So how does that layer 2 work? Well, layer 2 is a collective term for Ethereum scaling solutions that handle transactions off the Ethereum layer 1 while still taking advantage of the robust decentralization and security of that Ethereum layer 1 blockchain. So layer 2 is a separate blockchain that essentially extends the Ethereum network and runs on top of it. A layer 2 blockchain regularly communicates with Ethereum by submitting bundles and transactions or condensed compressed data of transactions in order to ensure it has similar security and decentralization that it guarantees. All this requires no changes to the layer 1 protocol, which is Ethereum. This lets layer 1 handle security, data availability, and decentralization, where the layer 2s handle scaling and increase capacity or the throughput of transactions on the network. Rollups are currently the preferred layer 2 scaling solution for Ethereum. By using rollups, users can reduce gas fees by up to 100x because what it does is it spread loads the gas fee across the layer 2 ecosystem. So rollups bundle hundreds of transactions into a single transaction on layer 1. And that's worth emphasizing. Rollups, so they bundle together, they roll up hundreds of different transactions into a single transaction on the layer 1. So you could have 100 transactions that occur on this layer 2, but they all get settled and finalized as a single transaction on the layer 1 Ethereum blockchain. This distributes the layer 1 transaction fees across everybody on the rollup, making it cheaper for each user. Rollup transactions get executed outside of that layer 1 on the layer 2 blockchain, but the transaction data actually gets posted on the layer 1. So by handling all these different transactions, you're increasing the number of transactions that occur, but the security and the decentralization is still maintained on that layer 1. So you still get the security of the Ethereum blockchain on this layer 2 scaling solution. There are 2 different approaches to rollups. So there's optimistic and zero knowledge. And they're really different primarily on how they update the layer 1 blockchain, which is Ethereum. For optimistic rollups, they're optimistic in the sense that the transactions are assumed to be valid, but can be challenged if necessary. If an invalid transaction is suspected, a fault proof is ran to see if in fact some sort of fraud has taken place. Whereas zero knowledge rollups are used as validity proofs where transactions are computed off chain and then compressed data is supplied to the Ethereum mainnet as proof to their validity. If you want to get deeper into the technical weeds, you can click these links to explain the math behind these different rollup theories. So how will Ethereum address its scaling solution without relying on layer 2? Well, there's something called sharding, which is going to address the scalability issue of Ethereum right now. Sharding was actually intended to come before the merge. However, with an emphasis and priority on making Ethereum more decentralized and secure, the Ethereum Foundation opted to have the merge come before sharding. So sharding is the process of splitting a database horizontally to essentially spread the load of that database. It's a common concept in computer science. In an Ethereum context, sharding will work synergistically with layer 2 rollups by splitting up the bundle of handling the large amount of data needed by rollups over the entire network. This will continue to reduce network congestion and increase the transactions per second. So really, if you think of sharding, like if you shard a glass together, you're essentially having different aspects of the transaction handled by different nodes on the network and then aggregated together to mean one final transaction or block. So it's essentially spread loading the workload amongst the validators within the network itself. Vitalik Buterin does an excellent job demystifying what sharding is, and I'll post this link in the description below. So really, if you think of it, you have the beacon chain, which is just acts as a coordination layer, and then all these different shards that are handling different data management tasks of what's going on the blockchain or of what the transaction is. So the easiest sharding to understand is through random sampling. So the core idea is as follows. Suppose that you have a proof of stake chain with a large number of validators, and you have a large number of blocks that need to be verified. No single computer is powerful enough to validate all these blocks before the next set of blocks comes, so they randomly split up the work of doing the verification of those blocks. We randomly shuffle the validator list, so if the validators are shown here below 0 to 17, they randomly shuffle them and then put them in different committees. And within those committees, they are validating different transactions that are occurring, and since they're randomly selected and they're all assumed to be honest participants, it spread loads the work across the network. So the network as a whole, by splitting up into these random sample committees, can handle more validations and more transactions ultimately per block. If you really want to get into technical weeds, there's an excellent hour-long guide by John, and it's called The Hitchhiker's Guide to Ethereum. So there's some key takeaways here, but he gets really deep into different types of sharding, something called dank sharding, and talks through the math and the science behind all the sharding techniques that they're going to be using in the future. So if this is something that's interested in, I highly recommend you give this article a hard read. Just know that it's going to take you about an hour to get through all that material together. So now you have a better understanding of what the merge is and what it means for you. If you're an Ethereum holder or you're soon to be an Ethereum investor, I'm excited to be on this journey with you. Hopefully the merge goes well mid-September, and I'm excited to see what follows with the layer 2 solutions as well as the sharding that will eventually take place. If you like this video, smash that like button. Comment below and give me feedback so that I can make better videos tailored to your needs. And if you like videos like this, hit the subscribe icon to see more content like this in the future. Thank you for your time, and best of luck on your crypto investing journey.